Hello students, in the last class we have seen about the first principles and we had derived certain results from the first principles. So let us see some of the more important results from the first principles of the derivative. So just to revise, what is the first principles of derivative? The derivative of a function fx that is shown by f dash x is given by limit as h tends to 0 f of x plus h minus fx divided by h. This is called as the first principles of the derivative. So let us see two important results from here. The first one is the derivative of a constant function is 0. That means I can say d by dx of k, where k is a constant, equal to 0. So in this case, first of all, what do we mean by a constant function? Just as a simple example, suppose I take a function fx is equal to 5. That means x may take any value, fx will always remain 5. So that means f of 1 will be 5, even f of negative 10 will be 5. So any value x may take, fx will take only one value, that is 5. Therefore, this is called as a constant function. So in this case, the function is fx is equal to k, a constant function. So f of x plus h will be also equal to k, because any value x may take, fx will remain the same. And hence by first principles, f dash x is equal to limit as h tends to 0 f of x plus h minus fx upon h, which is limit as h tends to 0. Now f of x plus h is k, minus fx is also k upon h. But k minus k is 0. That means this is limit as h tends to 0 of 0 upon h, which will be 0. And that shows that the derivative of a constant function is 0. Take for example, say derivative of root 5, the square root of 5 is a constant, so its derivative is 0. So let us come to the second result here. Derivative of k into fx is k times derivative of fx. Now in this case, this k is called as the coefficient of fx. So this coefficient, that is a constant with fx, can be taken out of the derivative, and then we can take the derivative of function fx. Take for example, suppose derivative of 2 into x square, 2x square. So in this case, 2 is a coefficient of x square. I can take it out of the derivative and multiply it by the derivative of x square, which is by the formula. What is the formula for derivative? D by dx of x to power n is n times x raised to n minus 1. So using this, I will get 2 into derivative of x square will be 2 times x to power 2 minus 1, that is 2 times x, and that is equal to 4x. So let us just prove this result. So in this case, I will take, say, the function gx as k times fx. Now why I am taking gx? Because already fx is there. So to avoid the confusion, so g of x plus h will be k into f of x plus h. I am replacing x by x plus h. And hence now I will write, instead of f dash x, I will write g dash x, and that will be limit as h tends to 0, g of x plus h minus g of x divided by h. So in this case my function is g, so I am using the first principles for g. So that is limit as h tends to 0, g of x plus h, that is k times f of x plus h minus k times f of x upon h. So that is, now I can take that k common. So limit as h tends to 0, k into f of x plus h minus fx divided by h. So that is, now here I can take this k out of the limit. So it will be k into limit as h tends to 0, f of x plus h minus fx divided by h. But that is nothing but k times f dash x. So that shows the derivative of k times fx. So this k is the coefficient of fx, which I can take out of the derivative. So k into derivative of fx. Just as one more example, suppose you have derivative of 3 times x cube. So here 3 is the coefficient which I will take out of the derivative. So 3 into derivative of x cube, and that is 3 into, now derivative of x cube will be 3 x to power 3 minus 1, that is 3x square. So finally the derivative will be 9x square. So these are the two results we are going to use. Just go through them. Next time we'll solve some derivatives on the quadratic function. So see you students. Enjoy the day ahead. Bye.